Good morning, everyone. Today we are going to talk about signals and circuit simulation. This is a very important topic in electronics and communication. So let's dive right in. Uh, Introduction. So let us start with what is signal. A signal is simply a function that carries information about the behavior or properties of a physical system. So think of it like a messenger that tells us uh, something about how a system is working, right? So signal can be of two main types. So the first one is a analog signal, and the second one is a digital signal. I think last class I already explained about analog and digital, but still uh, let me explain it again. So analog signals, these are continuous signals that can take any value within a range. For example, a sound waves, temperature reading, and voltage in a circuit. And last week I explained about the FM frequency uh, for analog signals, right? Because some radio stations, they say if you channel 98.1, you can hear us, you can listen to our music or broadcasting. But still, 98.1 means 98. If you channel 98, still you can hear. Or 98.2, still you can hear. So this kind of signal, normally analog signal has a range. Yeah, but digital signals, these are discrete signals that represent data in binary form, on and off, or zeros and ones. Example, I already gave you these examples. Computer data, digital clock, or signals in your smartphones. So the right hand side, I gave you the pictorial view of analog and digital. In addition to the analog and digital, we have some more signals. So we are not going to learn about these signals in this module, but I want you to know, right? So the third one is the periodic signals. That signal represent regular intervals. For example, sine waves or clock pulse. Sine waves in your high school, you learned about sine, cosine, that graph, right? So that kind of the waves is called periodic signals. And the non-periodic signal is that kind of signal that do not repeat regular patterns, right? So the random noise is a very good example of the non-periodic signal. The other one is the AC signals, alternating current signals that change direction periodically. The example is household electricity. The last one is the DC signal. DC signal is the direct current signal that flow in one direction only. So a good example of DC signal is your battery power. All right. So the next one is analog versus digital signals. We already discussed about this analog and digital signals, but still, let me explain. So analog signals continuous in both time and amplitude. So example is sine wave, voice signal, voltage, and voltage in a circuit. Those are the very good examples of analog signals. And the digital signal is discrete in time and amplitude. So the example is binary signal, digital communication in signals. The key difference between analog signals and digital signals. Analog signals are most susceptible to noise, while digital signals are more robust. Digital signals are easier to process and transmit over the long distance. So analog signal, you cannot it won't reach a long distance, but digital signals will reach long distance. For example, these radio waves, when you broadcast radio waves, you know, maximum the analog signal, you know, it will go up to 50 kilometers. After that one, you must have a relay to extend. But digital signals are unlike that one. It will go beyond, right? So here is the example of analog signal and digital signals. You can see the pictorial view of analog signals and the digital signals. Circuit simulation. Before we learn circuit simulation, you have to know what is circuit simulation. It is a process of using software to model the behavior of an electronic circuit, right? It's a process of using software instead of doing physically using the resistor and battery, and those are okay. We use a software to design first, then we apply that one in the lab. So instead of building a physical circuit, you can test and analyze it on your computer using the software. Then if everything goes okay, then you can build it physically. Normally, why you have to say, why do we use this circuit simulation software? It saves time and cost, right? And you can test circuits under different conditions. And the third one is it helps you understand how a circuit works before actually building it. That is a very important point. It helps you understand how a circuit works before actually building it, right? And these are the examples of the software, right? These are the common simulation software. So LT-SPICE is useful for it is a great software for analog and power circuits, and Protas is useful for microcontroller based design. Multisim, it normally supports both analog and digital. So in this module, we are going to use Multisim software in order to design the circuits. Very simple and good software. And the PS piece, it's an advanced tool for design circuit analysis, right? So those are the common softwares. We have it in the market, but we are going to download Multisim and then use it before we do physically. Circuit analysis technique. So what is circuit analysis techniques? The circuit analysis involves determining the voltage, current, and power in different parts of circuit, right? So to analyze circuits, we use some key techniques: Ohm's law, Kirchhoff's law, nodal analysis, and mesh analysis. You know Ohm's law. Ohm's law is V is equal to IR. It relates voltage, current, and resistance. The Kirchhoff's law, we have two types: Kirchhoff's voltage law, Kirchhoff's current law. Kirchhoff's voltage law, it sums of voltages around the closed loop in zero. Kirchhoff's currents law, it sums of currents entering a node equals the sum of currents leaving the node. And nodal analysis based on Kirchhoff's currents law, used to find voltage at different nodes. And mesh analysis based on Kirchhoff's voltage law, used to find currents in different loops. So this nodal analysis and mesh analysis, we are going to use, we're going to apply these techniques when we create the circuits. All right. The practical examples. So the practical examples, we are going to learn, I'm going to show you when we meet at the lab. So in the practical example, we are going to create a simple circuits with a voltage source and resistor and capacitor. So we normally identify the components and their values, then apply Ohm's law to find current and voltage across the resistor. The Kirchhoff's voltage law to analyze the loops and then simulate the circuits using software. You're going to use multisim to verify the results. Right, the simulation demonstration. This is also a practical. When we meet during the practical session, I'll explain. Right, we will open the software and build. We will build a simple RC circuit and then run the simulation, run the software, and observe the voltage and current waveforms. Then compare the simulations results with your theoretical calculations. All right, so that is the end of today's lecture. So far we learned analog and digital signals and importance of circuit simulations, and then key circuits analysis techniques, different types of laws, Ohm's law, Kirchhoff's law, right? And the next step, we are going to practice the circuits analysis problem and explore the simulation tool. We are going to open the simulation tool to build and test the circuits. Please go through this question and then share your thoughts on the importance of circuit analysis in IoT device. So thank you for listening. If you have any question, feel free to ask. You can communicate through Teams or Moodle, type the message or call me through Teams. I will clear your doubts. So let's make sure that you understand everything before we move forward, before we meet in the next lesson. Thank you.